Hey, welcome back, my fellow programmers. Here we are, still in Unit 3. I'm pretty sure if you watched the last video, I think I said that 3.6 was the last lesson of that unit. It looks like I completely forgot about 3.7, comparing objects. I should really go back and edit out that part from the last video, but then I would need to come into this video and edit out this part right here. So I think I'll just leave it in there. Hopefully you won't find this lesson as forgettable as I apparently did. Let's get started. We have one topic. It's about comparing objects. Our learning objective: compare object references using Boolean expressions in program code. Imagine for a moment someone were to ask you, where is Springfield? Now, if you were in Chicago, you might tell them, it's about a 3-hour drive south. To which they could reply, no, there's a Springfield in Illinois. There's also a Springfield in Missouri and Massachusetts and Ohio. And just because these towns have the same name, they are completely different towns with their own layout and their own population and their own personality. Here's an example of a class that we might use to represent a city object. On lines 2 and 3, we have our instance variables, a string to hold the name of the city, and an int to hold the population of the city. On line 5, you will see our constructor, in which we will accept a string for a name and an int for a starting population. We will take those parameter values and store them in the instance variables on line 6 and 7. And on line 10 tells us that we have getter and setter methods that are not shown. So we can imagine on the East Coast, there could be a city named Gotham with a population of 100 people. And on the West Coast, we can also have a city named Gotham with a population of 100 people. Even though all of the instance variables are set to the same values, these are not the same cities. If a person decided to leave the East Gotham and move to the West Gotham, then the populations would change. The East Gotham's population would decrease to 99, while the West Gotham's population would increase to 101. And then it's a little bit clearer that these are different cities. So just because objects have equivalent instance variables does not make them the same object. Looking at this in code on line 1, we are declaring a reference variable of the city class. We are calling it address1. And we are going to assign to it the memory address after calling the city constructor and passing in the actual parameters of the string literal Gotham and the integer literal 100. Now the keyword new will reserve space in heap memory for the instance variables of this object. The object has two instance variables. The first one is name, and that will be set to Gotham, and the second one is pop, which would be set to 100. In stack memory, we will have address 1, and that will hold a reference to where we find that city in heap memory. So it's telling us that we have a city at heap 01. Line 2 looks like a similar line of code. We just have a different reference variable. We have address 2. It is of type city, and we are assigning it the memory address that we get after calling the city constructor again, and we are still using the same actual parameters, the string literal Gotham and the integer literal 100. We are building a new city though, since we are using the keyword new. We are getting a new spot in heap memory. So the next available spot in heap memory, we will move those objects instance variables into heap memory. We have name being assigned the value of Gotham and pop being assigned the value of 100. Address 2 goes in stack memory, and it holds a reference to where we can find that city in heap memory. This one, we have a city at heap 02. Therefore, when on line 3, we say address2.setPop to 101, well, address 2 points to the city at heap 02, and we're going to change that pop to 101. And we don't change the population of the other Gotham that is at heap 01. They are their own unique cities with their own instances of the variables with their own unique values. We have our same two declarations on line 1 and 2. We see the same stack memory and heap memory on the right side of the screen. On line 4, we are declaring a Boolean value named B1, and we are assigning it the evaluated value of the Boolean expression on the right, in which we are asking if address 1 is equal to address 2. If we look in stack memory, address 1 holds the address city at H01. Address 2 holds the actual value of city at H02. These are not the same addresses. These addresses are different, so that will evaluate to false. B1 will hold the value of false. On line 7, we are declaring a Boolean value named B2. We are assigning it the evaluated value of the Boolean expression on the right-hand side, where we ask address 1 not equal to address 2. Again, address 1 is the actual address city at H01. We're asking if that is not equal to, and address 2 holds the actual address city at H02. Those do not equal each other. That will evaluate out to true, and B2 will hold true. This aligns with our essential knowledge. Object reference values can be compared using equal to, and not equal to identify aliases. We have a similar example here with a few changes. Line 1 is still the same. We are still calling the city constructor. We are moving in Gotham and 100 into the instance variables. We are creating address 1 in our stack memory. It is still pointing to the city at H01. Line 2 is where we see some difference. We are declaring a reference variable of the class city. We're naming it address 2, and we are assigning it the value of address 1. If we look at address 1 in stack memory, it actually holds an address. It holds the value city at H01. We are not using the keyword new on the right-hand side, so we are not reserving any space in heap memory. We are not calling the constructor, so we are not moving in any values into heap memory. The only thing that happens is that address 2 gets created in stack memory, and it holds a reference to the city at H01. Both of these are pointing to the same city in heap memory. That means on line 3, when we say address 2.set_pop to 101, address 2 points to the city at heap 01. We're going to change that population to 101, which just happens to be the same city that address 1 is pointing to. Next time address 1 checks the population, it will find that it has changed and it is 101. So when we look at line 4, when we are declaring and initializing that Boolean value B1, and we are assigning it to the evaluated value of the Boolean expression on the right, where we are asking if address 1 is equal to address 2, looking in stack memory, address 1 is the memory address city at heap 01. Address 2 is the address city at heap 01. We're asking if those two addresses are the same. That will evaluate out to true. On line 7, looking at the Boolean expression on the right-hand side of the assignments operator, we have address 1 again. We're asking if that is not equal to address 2. Well, we know address 1 is city at heap 01, and address 2 is city at heap 01. We're asking if those are not equal to each other. Well, that is false because they are equal to each other. That means address 2 is an alias of address 1. An alias is a reference to another object. This aligns with our essential knowledge. Two object references are considered aliases when they both reference the same object. We have another slightly similar code segment. Line 1 is still the same. We're using the keyword new to reserve some memory in heap memory. We're calling the city constructor to initialize those member variables. We are then storing a reference to that address in stack memory for address 1. On line 2, we are declaring a city. We're calling it address 2. We do not have an assignment statement. We do not have anything on the right. So we do not have that instantiation at all. We don't have the keyword new, so we are not reserving any space in memory. We don't have a constructor call, so we are not creating any instance variables. We don't even have a reference to another object there. We have nothing over there. Address 2 does need to get created in stack memory. Since we are not setting it to anything, there is a very special keyword that Java uses in this instance, and it is the keyword null. If on line 3 we tried to say address2.setPop, address2 does not refer to any object at all. There is no method to call. This would give us our null pointer exception. So if on line 4 we had a Boolean expression where we are asking if address2 is equal to null, if we check stack memory, address2 is null. We're asking if null is equal to null, and that's true. On line 7, looking at the Boolean expression, we're asking if address2 is not equal to null. Address2 is null. We're asking if null is not equal to null, and that would evaluate out to false. This aligns with our essential knowledge. A reference value can be compared with null using equal to or not equal to determine if the reference actually references an object. So going back where we are making our two different cities, our two Gotham cities that both have a population of 100, we know that they are different objects. If we look in stack memory, we are pointing to two different locations in heap memory. We have a city at heap 01 and we have a completely different city at heap 02. We know they are different objects, but sometimes we want to know if these objects have equivalent values, which they do. They both have the same name and they both have a population of 100. If equal to and not equal to just checks their values from stack memory, how do we check and compare their values from heap memory? Here we have that city definition that we saw earlier. We now have a new method at the bottom of it. It is the equals method. Looking at it, it has a return type of Boolean. When we use it, it will evaluate to a true or false value. The name of it is equals. And the parameter list, it is going to accept an object. We would want to know if this city is equal to another city. Inside that method, we have an if statement. We want to know if our name equals the other's name and if our population is equal to the other's population. If that's true, we're going to return true. Otherwise, we're going to return false. So if you want to know if your objects are equivalent, you will have to write your own equals method. And in that equals method, you get to determine what equivalent means for your class. I decided that all of the instance variables need to be the same. You might decide that your objects are the same if only the names are the same, or if only the populations are the same, or whatever equivalent means for the class that you are building. This aligns with our essential knowledge. Often, classes have their own equals methods, which can be used to determine whether two objects of the class are equivalent. Looking at our last code samples on the top, we are declaring address 1 and instantiating it as a new city. We are declaring address 2 and we are making it an alias of address 1. Both of these variables point to the same place in heap memory. Therefore, when we get to line 4, if we ask if address 1 is equal to address 2, they both hold the same memory address. That will evaluate to true. On line 5, we're asking if address 1 dot equals address 2. We are calling that equals method. The other address that we are passing in is address 2. We are asking if they are equivalent. Equivalent for our city class we decided meant have the same name and same population. Well, when we check the name of address 1 and address 2, they're both going to be Gotham because they're pointing to the same address. Same thing with population. They're both going to have the same population. This will evaluate to true because they are equivalent objects. Our second block of code on the bottom, we are creating two different city objects, address 1 and address 2. We are instantiating them using the same values for the member variables. On line 4, when we ask if address 1 is equal to address 2, that is not true. They are both pointing to different cities in heap memory that will evaluate to false. If we ask address 1 dot equals address 2, if we call the equals method and pass in address 2 as that other object, and we check if they have the same values for the instance variables, we would find out, yes, they both have the name Gotham and they both have the population of 100. So therefore, they meet our definition of equivalent, and that will evaluate to true. That might make you think about the string class because the string class works in a very similar fashion to that. All right, we're at the end of this lesson. I'm kind of nervous to say that we are at the end of the unit. I actually believe we are at the end of the unit this time, but I'm not going to jinx myself and actually say it. So just make sure that you rate how you are feeling on that learning objective. Read over your recap statements. Hit me up with any questions or concerns that you have regarding this concept. Join us in our next video, which may or may not be the next unit, and keep programming.